unions. We sometimes want to think about the same chunk of data in two or more different ways. And this is what unions are for. Let's begin with an example. We want to store the IP address as a DWORD, but also want to be able to access each byte separately. I want to explain for a moment. Maybe you have only heard about it once, about what an IP address is. Every computer in the internet has some address, and this address is used for communication. This is a very simplified explanation, but I just want you to have some background of the problem that we are trying to solve. So this IP address, at least in version 4 of the Internet Protocol, is composed of 4 bytes, or a DWORD. You've probably seen it like 4 decimal numbers which are separated by points. Maybe you have seen it once in your life. Usually, normal people don't get to see it because we have the domain name system, the DNS. Let's try to concentrate actually on what we try to achieve. We want to have a DWORD that we can also treat as 4 different bytes. For example, this could be an IP address in memory, and we want to be able to access each byte separately, but we also want to be able to access the whole DWORD as one DWORD. If we want to define this kind of structure, it is going to be like this. Struct IPv4, and we have the AND structure in the end, and inside of it we use the union directive. Inside the union, something pretty special happens. The offsets of the labels do not increase. Everything inside the union begins from the same place. So basically, a union gives you the ability to have different names for the same memory. In higher level languages, this kind of construct is very important because you don't have much freedom like you have as an assembly language programmer. But I wanted to mention it because it will give you new ways to think about data. And this is, in my opinion, pretty important. You always have to increase your vocabulary of what you can do with data. Here, for example, we have this union, and inside it we have 2 different things. We have this struct, which I consider to be one thing, and then we have this address, which I consider also to be one thing. So we have 2 objects inside the union. As I said before, inside the union, everything begins with the same offset. So we get that this object, which is made of 4 consecutive bytes, begins at offset 0, and also the second object, address, which is a DWORD, also begins in offset 0. So, as we can see in the picture, if we think about some relocation in memory, we have those 4 labels, IPv4.a, IPv4.b, and so on, and at the same time we have IPv4.address. We can see that IPv4.a and IPv4.address point exactly to the same place. Both of those numbers equal 0. Those 2 labels equal 0. As an idea to remember, unions basically create more labels with the same values. Let's talk a bit more about unions, because I want to cover some other ideas relating to this construct. Defining unions. Unions are defined inside struct definitions. So basically you cannot just create a union without having a struct. You got to define a struct first, and then the union is going to be inside. Unions are anonymous, which means that they have no name. The definition begins with the union directive and ends with AND-S. I want to emphasize it, AND-S also ends structs. So you can use this directive AND-S to end a union or to end the struct. Inside unions, the offset does not increase, as opposed to structures, where the offset increases for every field that you add. Let's look at a very simple example just to understand the difference between a structure and a union. Here we have our usual point structure, which contains just two fields, x and y. We know that x begins at location 0 and y is at offset 4. As opposed to this definition, we have PNT-U definition. Maybe you can think about this name as point union. And here we have also two fields, but they are inside the union, which means that they represent the same memory location. The size of this struct is going to be 2 D-words, which means 8 bytes. But the size of this struct is going to be 1 D-word, or 4 bytes. Basically we have pnt.x is 0 and pnt.y is 4. However, pntu.x is 0 and also pntu.y is 0. Basically x and y are just different names for the same location when we consider the pntu struct. However, in the pnt struct, x and y represent different locations in memory. Let's look at a picture. If we think about some 2 D-words in memory, then we have that pnt.x points to location 0 and pnt.y points to location 4. However, if we think about the pntu structure, which is basically a union, we get that pntu.x and pntu.y point to exactly the same place. Maybe a good way to remember it is that the PNT structure here is of size 8 bytes. However, the PNT-U structure, which is a union, is of size 4 bytes. I continue with the IPv4 example, and I want to show you some advantages of using a union, even as an assembly program. We have this union that we have defined of the IPv4. I remind you the structure here. This structure IPv4 is a union which contains two different representations for a D-word. The first representation is those 4 bytes, A, B, C, and D, which refer to the 4 bytes of the D-word. The second representation is as a whole D-word, which is called address. The total size of this structure, of IPv4 structure, is exactly 4 bytes, or 1 D-word. One of the big advantages of using a union is our ability to do something like this. Here in the data section, we initialize lhost, which means localhost. Just as a background, I can tell you that localhost means the address of our own computer, or it is also known as the loopback. Every computer refers to this address as his own address. But this is just an idea of what is the meaning of this IP. If you don't know anything about IPs, you don't have to worry. You can still understand this example. We can, for example, initialize our structure like this. We can just write 4 numbers. And this is pretty cool. Imagine, for example, that we didn't have this union and we only used a D-word. In that case, we would just have to write a very long number, which is not nice to look at. For example, this number. If we didn't have this union thing, we would have to write a very long number here, a very long D-word. By the way, I want to mention something. When you define a union, you actually define the same piece of memory in many ways. But in FASM there is a limitation. You can only initialize your construct by the first definition in the union, which means that this struct ABCD has to appear first inside this union if I want to use this form of initialization. If I wanted to use the dword form of initialization, then I had to change the order of this struct and others. I had to put others first if I wanted to initialize IPv4 as a dword. This is just a remark. Here we initialized lhost with those 4 bytes, and we can use it inside our code. For example, we can refer to it in more than one way. Here, for example, we read into EAX the dword from location lhost.address, which is basically going to read the whole dword. This is going to be the result. You can probably identify it by yourself. 1 corresponds to this one, then we have the zeros in the middle that corresponds to those 2 zeros, and finally 7f equals 127. You can check it out later if you are not sure about it. Next example. We can just read like this, move EAX dword lhost. And basically, the label lhost is exactly the same as the label lhost.address. Both of those labels point to the same location. This is not very new. I just put it to make sure that you get a connection between what you have learned before and what we have seen right now. Now to something more interesting. We can actually read from lhost using this structure from the union. So, for example, we can use d, lhost.d, and write a byte from this location in memory into BL. And the result is going to be 1. Just an example of doing it in the crude way. We could, for example, read from address lhost plus 3, which is also going to be exactly the location of lhost.d. Those two are exactly the same, lhost.d or lhost plus 3. This one is going to get us the same result, 1. Summary of what we have seen. Structures help us to declare meaningful objects in memory, and by meaningful I mean meaningful to us. In assembly language, structures are just a smart way to define labels. I want to remind you that they only help you to write your own program, but they cannot be seen in the resulting binary. This is pretty important. They are just a helper tool. They are not something that the processor can see or understand. Unions allows us to deal with the same memory location in more than one way. Which means that using a union, you can define the same place in memory, maybe the same dword, in 2 different ways, which can be useful sometimes. Some exercises. We've covered a lot of things in this lesson, and to make sure that you understand everything, be sure to do the exercises. Most of them are pretty simple, and I really recommend to go over all the exercises of the code reading and then move on to the code writing, to write some code yourself. Have fun with the exercises and see you next time.